Okay, so we're on, and you know, based off of Friday, what's your way out of this? Like as far as wait, I don't remember which one's which. I don't remember which one starts with an asymptote right at the y-axis, and which one. I know. What I'm doing is being that student where I forgot, and it comes back to chapter 3. I can't help you if this still is like cloudy to you. Why are you selecting these coordinates? Because it's coordinate trig that allows us to evaluate trigonometric things. So the first thing we're going to do is y equals tan x. What's he doing? Deriving real quick. Day 2, but, you know, let's get to the brass tacks of it, what we have to remember. All right. And then I have a coordinate plane here, which you have to equate is the x-axis is the inputs, the y-axis is the outputs. And when I input 0, which is 0 radians, what's the output? Well, tangent's y over x. Y over x is 0 over 1. What's 0 over 1? 0. So if you can do that, I don't know, it might be an if, then you can figure out that that's 0, 0 for tangent. That's where it starts. Now, of course, we're going to shift today. All you have to know is where it's shifted to, and then that's how it starts. It's the 0 coordinate. All right? And then, all right, now, okay, now I kind of remember. And I kind of remember that, oh, I remember this. This is pi over 2, and tangent of pi over 2 is y over x. What's wrong? I just did x over y. With my little arrows, but pi over 2 is x over, or y over x. Good Lord. All right, what's 1 over 0? All right, okay, wait a minute. Now I remember. He wore a shirt Friday, too, or Thursday. He wore his little asymptote shirt, remember? You shall not pass, with Gandalf right in the middle of a coordinate plane. All right, so, oh, all right, pi over 2 is there. And then here's negative pi over 2. And it's the same thing. At negative pi over 2, I get 1 over 0, negative 1 over 0, of course. And that, if I remember, and I described why that happens when we plugged in some more x, not too much, but, and then pi over 4, that's in quadrant 1. Tangent is positive in quadrant 1. Here's pi over 4 right here. It's a 45, 45, 90 triangle from chapter 3 and 2. All right, about 3 more about the pi over 4 radians. 1 over 1 is 1. And then negative pi over 4 is in quadrant 4. It's this triangle, a 45 that I wrote right there, and that becomes negative 1. So tangent increases. The parent does. And then for cotan, it's the same easy analysis. This is how you escape from maybe not quite being solidified on which one is which. Cotan is x over y. Now 1 over 0 is undefined immediately. And then, okay, so cotangent has an asymptote right at the start, and its next asymptote is the end of the period. And I could prove this real quick. Here's pi. It goes through negative 1, 0. There you go again. X over y is negative 1 over 0. And then all I have to do is cut it into halves and fourths. By the way, pi over 2 is up here, and x over y is 0 over 1, 0. So there's another discount double check. And then pi over 4 is in quadrant 1. I don't know why I put a negative there. Actually, I think that was supposed to be the top of my pi there. Pi over 4 is in quadrant 1, and cotan is 1 over 1. This is why this decreases when you're dealing with cotan graphs. And negative, wrong, 3 pi over 4, I'll put that up here, is the 45 in quadrant 2. And tangent's negative in quadrant 2. So it's negative 1. So we can equate this to some chapter 3 concepts to understand what we were kind of doing Friday, which is what I did a lot further than that. Now the brass tacks of it. Those are the key coordinates. And of course, that's the period. because it keeps repeating itself. Parent period of tan and cotan is pi. So therefore, all babies will be based off of that, pi over b, which we did do some changes on Friday with that. What's the amplitude, everybody? What's the amplitude? Come on, tell me. There is none. It's a jerk question by the teacher. Amplitude implies high and low values in sine and cosine. Only sine and cosine have amplitude by definition. But the A value is 1, and then all we're saying is if we throw a number in front of there, this just stretches or shrinks it, and we just mark it. We don't really show much about it. We just mark the number. Doesn't really change much. All right, and then I'm just going to give you a heads up that this book, and I know the homework assignment, does do a lot of what this first question does in the notes. So I did pull it right out of the homework. I don't know why they did this when they wrote the book. And what they did is they made phase shifts a little too large, and at some points, meaningless. And I want you to think about that when you're doing your homework tonight, that the book people kind of did that. Okay, so I'm giving you a minute to write it down. And of course, looking at the directions, graph a 2-period interval. Label asymptotes and critical parts. State all your stuff. Is all that says up there. Just no big deal. I'll press pause for a second, give you a chance to write. Resume. Tan, what do I got to do about this? What do I got to do about that 2 there? What do I have to pull out? Not a 2. A half. This is crazy. You got to pull a half out. When I pull a half out of x over 2, it does become x. What does pi become? It's actually 2 pi. Okay, some people said pi over 2. No. How do I know it's 2 pi? Good FOILers are good what? Good factors are good distributors. They check after they factor. What if I distribute that back? Do I get this? I've done this since August. That's what the whole point of good FOILers are good factors. They check. They don't just write an answer down and move on. All right? And it takes a millisecond at this point of our mathematical careers. Yeah, if I distribute a half into 2 pi, I get pi again. I'm good. Oh, this is what I'm talking about. What's the amplitude? They didn't say anything. Plus, they don't say it's Tuesday after a 3-day weekend. There isn't an amplitude, but 1 is going to be our little values that gives shape to the graph. What's the period? Well, it's pi, not 2 pi, pi over a half. What does that become? Now, this is where we have to think, guys. I'll reference again after we're done. What's the phase shift? What's the phase shift? How far left do I have to go? Oh, you got a message. I saw you look. Well, we just closed that. Okay, great. You don't have earbuds on because I noticed that this is playing some music. Oh, you have it paused. Got it. Just making sure. Okay. Yeah, these phones these days. No one answered the question. 2 pi left. Now let's talk for a minute about this. By talk, I'm going to talk and you're just going to listen. We're not going to have a conversation. All right? If I have a period of 2 pi, look at my hands. That means, okay, so I have a period and then I have a period, right? And then if I cut this period and moved it 2 pi to the left, wouldn't it just go this far? And then replace what just left completely? Like, if the period is equal to the phase shift, aren't we just cutting and pasting on top of what used to be there in the first place? And therefore, it is anyone? Meaningless. When the phase shift is equal to the period, you're just cutting and pasting from a previous period that just left. I don't know how else to explain this. The only way I can explain it again is after we draw our picture, then we'll say, oh, okay, I forgot to move it left. Let's move it left. Which means it's going to cut and paste right over what just left from that same position. I don't know how else to say it. Basically, what I'm going to say is you're gone. You are meaningless because you equal the period. And therefore, we can proceed on with this graphing a regular graph. This is like yesterday's, well, yesterday as far as school is concerned, which is Friday. All right, I'll explain it again. I see the deer in headlights look from some people. We'll do it. We'll do it. We'll do the phase shift 2 pi left after I do 2 periods. Okay, so what do I have to know about tangent? What does it start at? Does it start at an asymptote or 0, 0? What is the start of it? It's 0, 0. And then what do I put here? What do I put here? Don't say 2 pi. What do I put there? Pi. The way tangent works is, from your training, you take half the period, and that's where the asymptotes are. I just showed you the parent. Now the babies, they have the same attributes, it's just we're changing x values. We're changing, the x values. I guess that's the way to see it. I felt like I made a mistake by saying that. Then half of pi is pi over 2. And then negative pi over 2. I shouldn't go too fast, but I don't have a negative in front of the tangents. There's no flip. I ignored the phase shift because it equals the period. And I got the period as 2 pi, so yeah, that's a period of 2 pi right there. And then this is 1 and negative 1. Because of when I went over the parent stuff. And then it goes like this. Okay. 1 pi over 2. 2 pi over 2. Anyone? 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 I got some people. 3 pi over 2. 4 pi over 2. 5 pi over 2. And 6 pi over 2, which is 3 pi. This can be real delicate matter here. Nice. Should have planned for that. Right? And then this is where the next asymptote is. Whoa. You shall not pass. Yeah, we'll go right through that. Okay, here's my point. Oh, I forgot to move left 2 pi. So let's move this left 2 pi. Where does that land? Pi. So this goes right here. And this graph replaces this graph because this graph went over here. Do you get it now? You understand how I'm going to ignore that period, or I'm sorry, that phase shift? Because it just moves everything to where it was. This goes on forever. When you slide the graph equal to what the period is, it's the same graph. There is no change. Okay? So hopefully in visualizing 2 periods, you understand how moving 2 pi to the left does absolutely, positively nothing different. Okay, we'll get rid of that so he can concentrate. Here we go again. And actually, you know what? I just want to do it. I want to do it. Let's just change this a little bit. Plus 4. Who cares? Let's just add it. I didn't have this last time for first hour, but I just want to get it all together because the next one's like kind of really easy. But I wanted to put it all together here. But then actually talk to you about this phase shift. Okay, so first of all, we better know that we have to pull out a 2 at this point. Perfect little multiple choice on the test. Just what are the attributes? And I guarantee it's one you have to factor out the 2. Then identify what's the phase shift through a matching thing. So what does 3 pi over 2 become when you pull a 2 out? Well, it's 3 pi, Mr. S. Is it? Good FOILers, good factors. What's 2 times 3 pi? I'm tired of that mistake at this point. You're not a good FOILer, good distributor, or good factor, good distributor. That is an absolute nonsensical answer at this point. Do you understand me? All right. So what does it have to be? 3 pi over 4. Some of us still are not thinking. We just try to grasp at. I think he did this, and I think that's the answer, and you don't even check. Urgh. Okay. All right. Well, let's talk about what the amplitude is. I won't trick you. The amplitude's still 1. The period is pi over 2. And then what's the phase shift? Now here we go. What's the phase shift? 3 pi over 4. Now you can leave it, but I'm going to tell you there's an equivalent phase shift that's smarter to use. By the way, I added an up 4. It really doesn't change much in the graph. It just changed, we do our up 4 thing, and then we identify our new important points. And that's why I wanted to do that with this particular one. But here we go. Do you notice that the phase shift is blank compared to the period. There might be 2 words in there you need in that blank. Maybe blank, blank. The phase shift is blank, blank compared to the period. Okay, I'll add one blank. You got it! Shh, maybe they didn't hear you. The phase shift is blank than the period. Greater! So this is what I want to do with the phase shift to get an equivalent phase shift, and this should not confuse. 3 pi over 4 is 2 pi over 4 plus pi over 4. What's 2 pi over 4, everybody? Pi over 2. So the phase shift is a period and a half. So it cuts and pastes it on top of itself and then a half of a period more. Can't I just get rid of this and just do it a pi over 4? And the answer is yes. And that's what you should do to keep your graph relatively close to the y-axis. So because the phase shift is bigger than the period, we want to get a period out of it and get it to its smaller phase shift for our own ease and purposes. All right? So this is one where it's a little different. When the period is equal to the phase shift and vice versa, that's a great thing. Ignore it. This one's just bigger than a period. Get a period out of there, and it's going to be the same graph. And I can explain that when we actually come to it. All right, so what do we have to do for cotangent? It's moved up, so this is how we're going to do this. You already know it's moved up for, so put the x-axis way down here. All right, and since it's moved up for, I'm going to go by half marks, 1, 2, 3, 4. I shouldn't have to teach this anymore. You know you're supposed to do a new dotted line x-axis. This is where the new zeros will be located. Okay, so this is the new zeros, and it's still 0, where you get 0 for the function part, but then you add 4. 0 plus 4 is 4. That's why it gets moved up to there. And then big yawn back there, MG. All right, and then stealing all the oxygen from his fellow students around the area. Okay, what's the new high? No, it's not a new high point, but if 4 is there, what do I mark above and below that as our other critical points? 5 and 3, because A, not amplitude. But the new A values are you okay over there, student number 1? Oh, you were face down in your book. I thought you had just collapsed. Oh, okay, all right. Just making sure. All right, and then how? Okay, I'm such a maroon. I forgot to do our math off to the side. Remember when we have phase shifts that actually count? We do have to do our math off to the side. Okay, so 0 to pi over 2. What's half of pi over 2, everybody? See, there we go. That's how you know the phase shift is half of a period. If you were scared that I said that before. Pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. So I got ahead of myself with I got distracted with the moving up 4 that I forgot I had to do my x-axis work. It's the same as when we had stuff. Now, really hope this isn't causing problems. I am telling you right now, the homework, they are obsessed with periods and phase shifts bigger than the periods, or phase shifts equal to the periods, and then so that's why I feel as a teacher I want to get that out there, and it really shouldn't be a big deal. But all right, so we're going to go pi over 4 right instead of 3 pi over 4 right. Add pi over 4, add pi over 4, and all the way down, and then we're going to see a pattern. Reiterating, I'm going to move in on this, that the quarter value of the period is pi over 8. These are pi over 8 away, so when I write these are still going to be pi over 8 away. First one's easy. It's pi over 4. Or 2 pi over 8. This one is times 2 times 2. 3 pi over 8. Oh, okay. 2 pi over 8. 3 pi over 8. Anyone? Anyone? 4 pi over 8, which is pi over 2. 5 pi over 8. 6 pi over 8. And now they're moved. Now, notice what I said there too, and some of you got dinged on this. Go ahead and look at your quiz if you got dinged on this. Some of you put pi over 4 like right here, pi over 4, and then you went this far of a distance for the next one, 3 pi over 8. Why don't I like that? And sometimes it's really bad. Your first one was pi. Why don't I like that? That's supposed to be the origin. Are you telling me pi over 4 is this far? And pi over 8 is that far? No, that's not. Yeah, you are telling me that, and that's bad. So I got to think about this question a little bit further. Back, because it's harder to erase. You know what? I understand the whole pi over 8 thing. So I understand that that's pi over 8, and that's 2 pi over 8, which is pi over 4. And that's an appropriate distance, how far that is from the origin compared to all my other scaling. All right. Either do it or you don't on the next one. And you will be graphed on assessed on graphing and the precisions. That was mentioned before. Many gave it a whirl. Some of you put pi like right next to the origin or right on the origin. That is just completely incorrect, and it's got to change. Hey, how does cotan start now? Does it start with an asymptote or a 0? It's an asymptote. So this is still an asymptote, and now it's easy to go. This is still an asymptote, and this is still an asymptote. And the other dotted line is not an asymptote, but it's where the zeros are located. By the way, what is a 0? And then it's moved up 4. 3 pi over 8, pi over 2, or 5 pi over 8? It's pi over 2. It's the exact middle part's a 0, but then add 4. That's how that works. This is where this turns into 0, and then you add 4. That's how it ends up at 4. It's still a 0. The pi over 4 values are still undefined. Undefined plus 4 is still undefined. That's why those are still the asymptotes. And then I don't have a flippage of this, so cotan is high, and then it's not high point. I should not say that. All right, and then I also set this up for a second period. And the second period is, I know that these are pi over 8 away from each other, these little distances. That's why I left myself some pi over 8 distance here as well, because A, that's the right thing to do, and B, I can go ahead and get a second period. So what is this x value right here? I just said it twice, 3 times. What is it? Pi over 8. Is 0 part of it? You're dang right, because 0 is pi over 8 away from pi over 8. And now it becomes really easy. What are these and these? It's a cut and paste. Negative pi over 8 and negative pi over 4. And I think you're done because we have 1, 2, 3, 4. We definitely have that. And then, whoops, up here is a 0. This is, what always happens? I always try to avoid these getting hit by a graph, but. All right, so hopefully you can see the move up 4 is not a big deal. You just draw a new dotted line axis, and then treat that as the new x-axis. And then with the a values being real tight above and below those, the appropriate distance, which is 1 up and 1 down. All right, it's cotan. It does decrease. And I had this discussion with, again, just me talking and them listening. I always call them discussions. But it looks, isn't tangent start as a 0 on the y-axis, doesn't it? Doesn't it? Yeah, and you have to understand that cotan and tan are very similar. If I shift a tan graph and then flip it, it would turn into cotan. All right? I could turn a tan graph into a cotan just like that by putting a negative in front of tan and shifting it the right amount of right-left to make it land where a cotan graph would go. That's why there's an infinite amount of equations that could match one graph through shifting and flipping, either tan or cotan. And hopefully we understand it as we continue. Well, now this one's Mickey Mouse. Come on. Come on. Come on. Hey, what's the 1 do? Oh, it's right on there. What's the period? What's the period? Pi over 1, they are whispering. It's Tuesday after a 3-day weekend. This always happens. Okay, but we definitely have a flip over the x-axis. This one is a super quick one. Now that I did the up-down thing in the previous question, this should be so easy. Okay, and hopefully you're listening so we can just get the brass tacks of this done, and then we can move on with leaving you alone. All right, the period's pi. So what am I going to put here and here at the two ends here? It's not pi, it's pi over 2. You cut the period in half because those are the rules for tangents. And then half of pi over 2 is pi over 4. All right. Oh, okay. I got to move up 1. And I do want to make this dotted line so I don't forget. And I am going to extend that probably, but you know what? I'm going to show you. I'm going to show you what I did first hour. All right. And then what's tangent start at? A 0 or an asymptote? It's a 0, but then it's moved up 1. And then you got to be careful. Okay, these are the asymptotes. Undefined plus 1 is still undefined. It's actually a true statement, what I want to be sharing with you. All right, and then it's an upside down. So my new values are 2 to 0, right? Because the amplitude is still wrong. No amplitude. But the A value is still 1. So it's 1 above and 1 below the dotted axis. The new x-axis. All right. But this one now is this because of the negative in front of tan. It is flipped over the x-axis, so it now decreases. Then this is what I was saying before. If I shift this pi over 2 to the right, then it's exactly a cotan graph that's moved up 1. And you should see that because cotan decreases like that. Now, 1 pi over 4, 2 pi over 4, say it. Now watch what I do with this. This is legal. 4, but not many things legal in Mr. Samuels' class. This is one of them. Hey, that'd be a 0. And then this would be 2. I'm sorry, that'd be 1. And then can I just graph that? Stop. And then come over here and cut and paste and do this. And does that represent a second period? What do you think the answer to that is? Abso-fruitly. Okay, so then this is this 0. Oh, sorry, I almost screwed that up. And then this is that part, the bottom part of the curve. And that represents a second period. That's what you see a lot of time when you look in the book for answers, right? That's what they do. So we could do that as well. It makes it easier for, finding out x values, as long as you find those couple ones. I forgot to do this the whole time. Let's go back up to this one. Why this one? It's a little different. Let's do the domain thing and the range thing. And you could do that. You can switch gears on that just to remember, because this one's a little bit better. The last one was more like the parent. What can x equal? Well, you pick one. What's the first nice positive one? What's the first nice positive bad value? Pi over 4. And then add or subtract. How far away are each one of those asymptotes away? It's the period, and it is pi over 2, and I have that in yellow over there. Range is always all real numbers. I don't even feel like writing that. I'm tired. Asymptotes are vertical lines, so they are x equals a number, and it's the same dang number as the domain issues. Because the asymptotes are the domain issues. Did I not put an N on there? Yikes. I have a hand up there. It's usually a student that catches me on my little mistakes. Was I right there, student number 2 in 4th hour? Nice. Is everyone okay? Who said no? Uh-oh, I got to go do something. Now I got to become psychiatrist Samuelus. Oh, could you imagine solving people's problems?